Alright, so we looked at multiplying containers, matrices yesterday. I thought we'd do a little bit more practice with that and extend it a little further today. So we have two matrices here, R and B, and we're supposed to find the matrix product both ways. We learned yesterday that matrix products, unlike regular products, sometimes don't, what was the word? Kyle? Yes. So that's a special property in math. 7 times 3 equals 3 times 7 is something you're used to working with forever, which is not going to be true in this chapter. What's that property called, 7 times 3 equals 3 times 7, Joy? Commutative property, yeah. So matrices do not commute. That doesn't mean they don't drive to work together. That means they do not do this. Okay? So RB, can we find the matrix product RB for this problem? When you look at these, if you try to add them together, of course you can't do that. You can't subtract them. Can you multiply them in the order RB? Well, you got to check, right? You could start going with your little robot dance, or you could just write the dimensions down. This dimension is what? 1 row by 4 columns. This one is 4 rows by 2 columns. Can we do it? Yes. The inner dimensions match. What size will the answer be? 1 by 2. So this one should be a pretty quick multiplication. That's why I didn't give you guys a whole lot of time on it. So let's write it out and do it. So R, I'm going to write it again. And B. And we set up our container to be a 1 by 2. That means 1 row, 2 columns with just 2 entries. This is going to be a quick one. Okay, time for dancing. Worst dancer ever, but it's okay. So we're going to go 2 times 1, slide, plus -15, plus 12, plus nothing. How you show that work is all up to you. I'm going to write it down on the first one, then I'm not going to. So the first one, I'm going to say 2 times 1 is 2. Slide. You guys said -15. Slide. Plus 12. Slide. Plus nothing. So that's 14 minus 15 is -1. This time I'm not going to keep track. But it's all about not making mistakes here, right? So you do what you have to do in order to not make mistakes. So 4 plus 30 is 34. Don't go too fast. Plus 24. Oh, 34 and 24. I better start writing this down. I'm having trouble keeping it in my head. Plus nothing. So that's what, 58? So RB is the matrix with those 2 entries in it. If we try to do BR like they asked us to in this problem, could we do that? No. You could go ahead and write them down next to each other. You could write the dimensions down. There's all kinds of ways to see it. My favorite way is this. Just write B, the dimensions of B, the dimensions of R. Those do not match. So this cannot be done. If you tried to do it and you went, I guess I need to write this one over there, but we'll try to disobey the robot dance. This way, and you try to go this way, you're going to be like, okay, 1 times 2 is 2. Slide, and you're outside the box. You can't do it, right? So that we call what? Undefined. Has no definition. Sweet. One other thing that you guys are going to be asked to do is square, cube, or power matrices of different powers. I thought we'd start with matrix H, a nice little 2 by 2, and square it. So how do you square a matrix? Here's the mistake that people make on my tests. And this is an easy problem, I think, on the test, not a hard one. But you have an idea, Cameron?
Yeah.
What is it?
Squaring means you just multiply something by itself, so you're just going to put that matrix beside it.
Yeah, so is this what Cameron means?
Well, that's the total side.
Is that what Cameron just said? Not at all, right? She said squaring means like doing that thing times itself twice. I think that's what she said, basically. It's not this. You can't just square the individual entries in matrix land. That doesn't work. So will it end up being that or not? Good question, Richard. Let's remember this. you guys want to write it down, you can. This is the very wrong answer. You can put a big not equals there. But let's see. Maybe it does work if we do it like Cameron said. Cameron said to do this. Write it down once. There's H, and here's H again. Can we do that multiplication? I think this time it's pretty easy to see yes. We don't really need to check stuff, right? 2 by 2, 2 by 2, yes. And the answer is going to be a 2 by 2. So we're going to put a 2 by 2 over here with 4 blanks and do them. I'm going to write a couple down. I'm not going to write a couple down. 36, slide. What's half of 4? 2. So I've got 36 plus 2 is 38. Half of 6. Slide. Half of negative 2. Negative 1. So this is how I like to do my scratch work. You might have different levels of scratch work that you feel comfortable with. It's up to you. You might even want to write it all the way. So I did that row. I used it up, hitting all the columns. I'm going to do the same thing with the other one. So I'm going to go 4 times 6. Really write it out. Here you go. Slide. Negative 2 times 4. So it's 24 minus 8, 16. And now I need to hit the other column with that row. So half of 4 is, better put some bullet points here, is 2. Slide. Negative 2 and negative 2 is 4. So this should be 6. Is that what we just had on the board a second ago that you guys wrote down? It's like totally different, isn't it? It's not even close to the same. Are they like 2 off? So is there some kind of other theorem that you could relate those to? Possibly. I don't know it though, and I've taken 4 classes in linear algebra, so it might be something that slipped by me that I never noticed. I can't remember. So anyway, that's how you do h cubed, h squared. How would you do h cubed then? Because you have 1 or 2 in there that ask you to do something cubed. You'd take that, I'll try to remember the colors. And do what with it? Multiply it by another h. We're not going to, just to save time, but that's how you do h cubed. I think I just gave you one of those, okay? So don't just square the entries or cube the entries, that's not going to work. Not how matrices power. All right. I think you guys should take some time. We'll come back and do an application, and we're going to do something 3-dimensional today, but I'm going to give you guys about 20 minutes first, so take 20. Okay, so we're going to look at our first matrix application right now. This one is about locating a treasure using a matrix product. This is like, I guess, some kind of game show, and the contestants have to find a matrix product and use that matrix product to find the treasure in the first stage of, this sounds like what game show? The one where they like travel around the world. What's that one called?
Amazing Race.
Amazing Race. I was thinking of the Amazing Race when this problem came up. So, yeah. So first, we need to find the matrix product. And that's the strategy you should approach on all the applications in this section. Don't get overwhelmed by what you need to do. They want you to find matrix products because that's what we're practicing, right? And using them for different things. Find the matrix product before you even read the question really thoroughly. Then go back and see specifically what did they want in the matrix product. Did they want all of the entries? That's unlikely. They're probably going to be asking you for a couple specific ones, or like one row is going to have all the numbers that they want, or maybe one row is going to have all the numbers that they want, or one column, or maybe they want the things on the diagonal. All those can have different kinds of meanings. And if you just find the product first and then look at the matrix and try to figure out where's the costs, or where's the location for the treasure, you won't have trouble, I promise. They aren't that bad. So let's find the product first. I'll take my own advice. Here we go. You guys help me out. 6 plus negative 12. What's 6 minus 12? Negative 6. There we go. Next is negative 18. And nothing. It's nice. We love zeros in matrix land. If you haven't figured it out yet, you're going to tomorrow. 2. So 2 minus 24. negative 22, right? And then negative 6 and 0 is negative 6. Okay, so we found the product. Now we need to know, what did they ask us to do with that product? Well, they said there's a treasure, that's why I called it capital X matrix. You guys get it? Capital X matrix. And it says in the capital X matrix, the latitude of the treasure is given where? 1, 1, that's its address. So what's the location of our treasure latitudinally? Negative 6. They wanted us to look here. That's going to tell us latitude. Let's do a little geography review. Latitude. Is that like up and down, left or right? Think about latitude lines. These, the equator is the main latitude line. And so like these cross sections would also be latitude lines. So that really tells you up and down. Latitude and longitude are kind of weird. So if it's negative 6, that means go down 6. So that's like negative 6 which way? I bet they're trying to say like negative 6 degrees.
Yeah.
South. The treasure is negative 6 degrees south. I mean, we're gonna be from some specific location, so I guess we'll just say that we're down here on the Galapagos Islands on the equator. So negative 6 degrees south from the Galapagos Islands. Does that make sense? You'll see on your problem, it's real simple. And then longitude, where are we supposed to look for that? We're supposed to look here, which coincidentally on this one is also negative 6. So that's longitude. Longitude lines look like this, like the prime meridian is the main one. So that's like negative 6 means like that way, right? Negative 6. So which way is that way in your direction system? So it's negative 6 degrees which way? North, south, east, west, degrees west. There you go. There's one application. I will be filming another one probably tomorrow morning or later this evening. We'll see. The thing you guys should follow is find the product, then look at what they want out of that product. They want the diagonals, they want just these top things. You got to think about it for a second. If you do, I don't think you'll have any trouble. See you next time. So, another matrix application. This one we're looking at 3 stores. We've got Costco, we've got Best Buy, we've got Target, and I picked some stuff that I thought those stores sold. Clothes, TVs, and movies. You guys are like, Best Buy doesn't sell clothes. They sell things kind of like clothes though. They like sell some accessories, don't they? Like fancy iPod things you can put on your shoulder and stuff like that. I'm counting those as clothes. Okay? Maybe they...
If it was in a different...
So, we've got costs, we've got profits. What's the other element of selling stuff in business that we don't have numbers for? Revenue. Revenue is the price that you pay when you buy something. So, I had a question a second ago which was really good, which was, how are the costs less than the profits? Like, how does that work? What's the revenue for those items in the bottom row of the cost-profit matrix? What's the revenue? You guys have computers open. Kyle? 14. You pay 14. The company, for whatever that was, paid 4. So that means they have a profit of $10. Does that make sense? So what was the revenue for the 300 row? 600. What was the revenue for the 8-6 row? 14. That's how the company, that's what the company charges you, and the cost profit breakdown is right there. So I just chose to do this. So when you're doing a problem like this, my overall recommendation when doing applications like this is find the product first, just find it. Then look at your product and try to figure out what they asked you. Did they ask you for the entire product matrix? Did they just ask you for one row, or just maybe one entry or 2 different entries in it? If you just find the product first and then go back and see what question they asked, it'll be oh so much easier. Now we have some large matrices here, right, with big numbers, so I figured I'd show you how to multiply them with your calculator. Can we do it first though? Can we multiply that first matrix by the second matrix? How do we check? This is what size? 3 by 3. I know it doesn't look like a matrix, but close enough, you can see it, right? What size is this? 3 by 2. So if you put those right next to each other, can you do it? Yes. What size will the answer be? 3 by 2. But our calculator is going to do it for us this time instead of us doing the Michael Jackson robot dance. Okay, so here's how you enter them in your calculator. There is a special button that says Matrix. Who can tell me where it's at? Cameron.
It's on your map.
Second, x to the negative 1 power. It's on the left side of your calculator. It should bring up a menu that looks something like this. Yours might look a little different than mine. It says names, it says math, and it says edit. We want to edit what is in our matrices. So you go over here, watch the menu, it'll look exactly the same. This is where you grab them. Looks exactly the same. This is where you edit them. Let's put matrix A as our first one. So 3, enter 3. So 3 by 3. Then put your entries in. Alright, I'll let you guys do that. So 100, 30, 45, 10, 70, 243, 320, 15, 65. Alright, I'm just going to quit and go out to the home screen. Second, quit. And now I'm going to go do the exact same thing with my other matrix. So I'm going to go second matrix, and this will be in the video, so you can look at it again later. If I press B right here, it brings me up to the home screen because I grabbed B. Here's what was in my B. I don't know what that stuff is. We want to put different stuff in our B, right? So second matrix, go over and edit it. Our matrix is a 3 by 2. If you're unsure, just like press buttons until it looks like the thing on your paper. It's not that hard. So 8, 6, 300, 300, 4, and 10. And I'm going to quit. To find my matrix product, I need to multiply the matrices, so I go grab them. So I go second matrix, grab. Times second matrix. Now I want to grab B. And I do it. And there is the matrix product. Now I've got the product. So this was an application. What did they ask me to do this time? The question was, what are the profits made by the 3 companies this Saturday? So which numbers in there tell me the profits from 3 companies? Everything?
No.
No. Here's where you might want to think about this. This is why just using your calculator to multiply things doesn't get the job done. If we were going to multiply this by hand, we'd have gone row, right, by column, and we'd have hit the cost column, and we'd have hit the profit column. Do we want the cost column answer for Costco? No, we want the profit. This one is that one. That's the profit for who? Costco. This number, 7070, we'll assume it's dollars, so $7,070 is what who made on Saturday? Target. And where is the number for what Best Buy made on that Saturday? 23,490. If they asked me for the costs, I'd be looking here. If they asked me for the revenues, could we do that? The answer is yes. We could just add these 2 numbers and get the revenue for Target. We could add these 2 numbers and get the revenue for the other one. I don't think you're going to have anything that's that involved. Yours are basically find the product and look at a certain spot in it. If you do your matrix, oh man, do your matrix dance, you're going to know where to look. Okay? So there's an application for you guys. And now you can multiply with your calculator. Should be something I think you'll find useful.